Picture a world where the devices we use daily are not just more powerful, but also kinder to the environment. Today, we unlock the potential with our computing systems, particularly the central processing units, revealing the key to a greener and more substantial technological future. Imagine devices that excel in performance while leaving a smaller environmental footprint. A future where innovation meets environmental responsibility. Thus, the topic of green computing. What exactly is green computing? In simple terms, green computing is the practice of using computers and other computing devices in energy efficient and eco-friendly ways. As discussed in the article, researchers calculate path to green computing. A failure to prioritize energy efficient computing can lead to inefficient workloads. The future of our world centers around technology, making it crucial to grasp not only the strides in technological progress, but also its impact on Earth. Fortunately, Intel CPUs play a vital role in advancing green computing and sustainability by continually evolving great energy efficiency. As a computer science major, I'm often marveled at the seemingly magical capabilities of the small square-shaped piece of technology known as the CPU, or Central Processing Unit. The CPU is the brain of our computing devices, responsible for executing instructions, performing calculations, and managing data. It's a powerhouse that enables our computers to process information swiftly and efficiently. Emphasizing the pivotal role of technology and the pressing need for environmental responsibility, let's now focus on a cornerstone in computing history. We kickstart our journey with the introduction of Intel's very first commercial CPU that was created for laptops and desktop PCs, the Intel 8086. According to the history of Intel processors, the Intel 8086, introduced in 1978, featured 29,000 transistors responsible for managing data transfer between different components with the CPU. Clock speeds ranging from 5 to 10 megahertz denoted the processor's operation speed and achieved up to 0.75 MIPS, or million instructions per second. The Intel 8086 demonstrated remarkable efficiency in processing during its time, showcasing the prowess of the x86 architecture that would go on to shape the future of CPUs. With the introduction of the 80286 in 1991, a momentous leap in technological improvement unfolded, setting a path towards sustainability in the realm of processors. According to the history of Intel processors, with 4 times the MIPS and almost 5 times the clock speed of the 8086, significantly improved the performance. This faster and more responsive task execution inadvertently contributed to reduced power consumption and extended the lifespan of computing systems. In the modern computing landscape, the 12th gen Intel Core i CPUs featuring the powerhouse i9 12900K brought a substantial performance boost. According to Maria Ridias, in Intel CPU generation Core i series and beyond, the processor boasts a remarkable 5.3 GHz speed and 16 processors. Compared to the previous series, the 12th gen Intel CPU demonstrates a remarkable 75% increase in core speed and a doubling of the core count. Despite a slightly lower clock speed, the introduction of the x86-64 architecture enables more efficient processing, making the CPU faster. In 2021, the i9 12900K has a clock speed of 5.2 GHz, over 100 times faster than the 8086. Additionally, the x86-64 architecture allows for more efficient processing, handling data in chunks of 64 bits instead of just 32, potentially making the CPU faster and more powerful while consuming less power than the original x86 architecture. Moreover, with the release of the Intel Core i 12th Gen, Intel has achieved high milestones in terms of green computing. As stated in Green Processing, how Intel's Meteor Lake champions sustainability, in 2022, Intel reached 100% renewable energy utilization in the US, EU, Israel, and Malaysia. Additionally, they are nearing the 100% mark in Costa Rica, contributing to evaluating the usage to an impressive 93%. Transitioning from the realm of consumer-grade CPUs to the professional domain, let's delve into the world of Xeon processors, a line of CPUs crafted by Intel to cater to the heightened demands of enterprise-level computing and robust workloads. One of the first processors ever created was the Pentium II Xeon. According to the history of Intel processors, the Pentium II was released with the 350nm Klamath core and soon shrunk to a 250nm core and clock speed to 450 MHz in 1998. The reduction in core size often signifies advancements in chip fabrication, leading to improved performance and efficiency. The mission of clock speeds reaching up to 450 MHz reflects the continuous efforts to enhance processing power. The transition from consumer CPUs led to the unveiling of the Pentium 3 Xeon, designed to compete with AMD's Athlon CPU. This advancement brought about a reduction in size and an increase in clock speed from 450 MHz to 1,400 MHz. Significantly, a newer generation of architect was implemented compared to the previous versions, enhancing the overall efficiency of the CPU. Let's skip ahead to the more recent times, focusing on the current Intel Xeon CPUs. With the release of Xeon CPUs also came the release of a new architecture, NetBurst. According to the history of Intel CPUs, similar to its desktop processor, the NetBurst processor suffered from excessive power consumption, which forced Intel to revise the processor's architecture and strategy. The NetBurst Xeons died with the dual-core CPU with a clock speed of up to 3.73 GHz and 378 transistors. Intel initially encountered challenges with this novel architecture. However, after a reevaluation and a commitment to green computing, Intel made adjustments. The clock speed was reduced from 3.73 GHz to 3.46, and the number of transistors was increased to 2.6 billion. This shift followed the Sandy Bridge EP architecture, aiming to address the issue of excessive power consumption. A prime example of this will be in the article, an EMC-based energy-efficient optimization approach for bandwidth-limited streaming kernels on recent Xeon processors, stating, "We found energy consumptions can be reduced by a factor of 2.1x on Sandy Bridge EP, which proves even further optimization in Intel's Xeon CPUs to promote greater energy efficiency." Intel's dedication to advancing CPU technology has far-reaching implications for both the technological landscape and environmental sustainability. The evolution of Intel CPUs marked by breakthroughs in architect and clock speeds contributes significantly to the progress of green computing. As our world becomes increasingly more reliant on technology, Intel's commitment to improvements align seamlessly with our vision of a more eco-friendly future.